So here, revisiting a projectile. So we've seen a quadratic function. You can model the height after time. So one thing here, we have negative 5t squared plus 27t plus 18. This is in standard form. And just a reminder, one thing that you can recognize from standard form, this right here is gravity. And this right here is your initial velocity. And this is your initial height. So to use the zero product property to find out when it's hitting the ground, this equation will help you to figure out when does it hit the ground. So what you can do is you plug in 0 for the height. So you would have 0 equals negative 5t minus 3 times t minus 6. And then set both pieces equal to 0. T minus 6 equals 0. And negative 5t minus 3 equals 0. So add 6 here. And you get t equals 6. Add 3 here. And you have negative 5t equals 3. Then divide by negative 5. And t would equal negative 3/5 of a second. So let's change that to a decimal. So negative 3 divided by 5. Make sure you put in a negative and not a minus. And it's negative 0.6. So on here, we use factored form to find the zeros. And really, only one zero makes sense. So t equals 6 seconds here is the only zero that makes sense. So for our other part, without graphing, determine the initial height. So we're going to use standard form. And our standard form of the function is h of t is negative 5t squared plus 27t plus 18. Again, this negative part, that is the effect of gravity. And then here, this 27t, our linear part, is the initial velocity. And then here, this 18 is our initial height. So our initial height here is going to be 18. And I'm not seeing units here, so we'll just assume that that's feet.